So at first, this looks very strange. Rewrite this expression, the tangent of the sine inverse of x, so that it only has algebra in it. So it does not have any trigonometry. In other words, eliminate the trigonometry. I'm going to start right here, sine inverse. So if you take sine inverse of something, then what you get is an angle theta. Next, I could take sine of both sides, eliminating the sine inverse on the left, and it'll say x equals sine of theta. Well, that means that somebody had a right triangle. Theta was the angle, and sine is opposite over hypotenuse. So when they divided the opposite and the hypotenuse, they got x. For this x right here, I could rewrite it as x over 1. So that means the opposite side is x, and the hypotenuse is 1. So this side is x, and this side is 1. Then for this missing side down here, we could call it some letter like b and do the Pythagorean theorem. So b squared plus x squared equals 1 squared. And what I need to do is solve for b. So subtract x squared from both sides. B squared equals 1 minus x squared. And then take the square root. Oops, that's supposed to say minus. 1 minus x squared. The reason that my brain just wrote a plus right there is because it was trying to remind me that when I take the square root, I need to put plus or minus the square root. But inside it's supposed to say 1 minus x squared. Okay, now this was saying find tangent of that. So how much is tangent of theta? Well, tangent is opposite over adjacent, so that would be x over b. And then for b, we just found out that it equals this over here, plus or minus the square root of 1 minus x squared. And now we could replace this theta because theta equals sine inverse. So the final answer is tangent of sine inverse is equal to x over the plus minus square root of 1 minus x squared. So we've taken something that has trigonometry in it and replaced it with something that only has algebra.